All right, hey kids, welcome to section 4.4 counting rules. Today we're going to learn about something called the fundamental counting rule, the permutation rule, and the combination rule. All about probability and outcomes. So we've got the first thing, fundamental counting rule. So we learned in a previous section that we can use multiplication to help us find the probability of something occurring. Well, we can also use multiplication rules to find how many outcomes there will be, how many different combinations there can be. And so, this thing called the fundamental counting rule says that if you have a sequence of n events, and each of these different things that make up the events have different numbers of possible outcomes, K1. Second event has K2 outcomes. The third event has K3 different possibilities. If we have all these different things that make up this big event N, I can multiply all of their probabilities together, and that's going to tell me the total number of outcomes that an event could have. So, for instance, if you are tossing a coin and rolling a die, so you've got a coin is tossed in the air and a die is rolled. Find the number of outcomes for the sequence of events. Well, when I flip a coin, there are two different outcomes that can happen. When I roll a die, there are six different outcomes that can happen. So to find the total number of outcomes, all I have to do is multiply them together. There's 12 different ways that when I flip a coin and roll a die, I can have happen. All right, this one's about paint. A paint manufacturer wishes to manufacture several different paints. The categories include the following: how many different kinds of paint can be made if you can select one color, one type, one texture, and one use? Well, if you look in the table over here, we got 1, 2, 3, 4, 5, 6, 7 different colors. There are 2 different types of paint. There are 3 different types of textures. And there are 2 different types of use. So if I'm picking one of each, then there are 7 times 2 times 3 times 2, which equals 84 different possible types of paint that I can make. So take the number of possibilities for each part of the event, multiply them together, and you have the total number of outcomes. All right, so we can also use this to help us when we repeat things. So, for example, something to remember is when determining the number of different possibilities of a sequence of events, you must know whether repetitions are permissible. So that means that, let's say I have a license plate. Am I allowed to use the number 1 for every single space, or do all the numbers on the license plate have to be different? And if you use letters, can they only be in certain spots? Can you use a letter more than once? You got to know what the rules are before you can figure out the number of outcomes. So let's use that for the next two. There are 4 blood types: A, B, AB, and O. Blood can be Rh positive and Rh negative. Finally, a blood donor can be classified as either male or female. How many different ways can a donor have his or her blood labeled? Well, in this situation, you're obviously not going to repeat your blood type or your gender or whether it's positive or negative. So you're going to take the number of types of blood, that's 4, and you're going to multiply it by the number of types of positive or negative there are, which is 2. And then you're going to multiply by male or female, that's another 2. So you multiply these together and you get 16 different ways the blood can be labeled. All right, then we got license plates. The first year the state of Pennsylvania issued railroad memorial license plates, the plates had a picture of a steam engine followed by 4 digits. Assuming that repetitions are allowed, how many railroad memorial plates could be issued? Okay, well, you've got a train, don't make fun of me. So here's the wheels and they get smoke coming out. Okay, after that, I have 4 digits. Well, how many different possibilities are there for the first spot? There's 10. Don't forget 0. 0 through 9 are the digits you're using. And since I can have repetitions, there are still 10 different numbers to use for the second spot. And there are still 10 for the third, and there are still 10 to the fourth. So we multiply the number of possibilities together, and that gives me 10,000 different memorial license plates. Okay. Now, this idea of repetitions is what leads us to the next topic, permutations. So remember, if repetitions are permitted, hopefully you notice that the numbers stay the same going left to right, like in the previous problem. That was 10 times 10 times 10 times 10. However, if repetitions are not permitted, then the numbers are going to decrease by 1 for each place left to right. So, when they decrease going left to right, that introduces something called a factorial. And here is the definition of a factorial. N factorial, which indeed is an N with an exclamation point. N, by definition, is you take that number N, you multiply it by whatever is one less than it, N minus 1, and you multiply it by one more less, so N minus 2, and you keep going until you get to 1. So, for example, if you were trying to do 3 factorial, that would be 3 times 2 times 1, or 6. This idea of a factorial is useful in doing permutations, and that's when I'm putting n objects in a specific order. So here's 10 books that I want to put on a shelf. They go in a certain order. Here are 4 books that I want to read in a certain order. The only weird one about factorials is 0 factorial is 1. Now, usually factorial means multiply it by that number until you get to 1. Well, it's weird because 0 factorial, yeah, it's weird. You just got to know that 0 factorial equals 1. However, if you ever forget, you can always use your calculator because guess what, kids? There's a factorial button on the calculator. So if you grab your calculator and you go to math and you go to the right to prob, right there on number 4 is the factorial button. So let's see, I'll do 3 factorial. So 3, I'm going to type 3, I'm going to hit math, I'm going to go to prob, I'm going to go to number 4, factorial, and hit enter. So 3 equals 6, just like we calculated. Awesome. All right, so let's do an example. Suppose a business owner has a choice of 5 locations in which to establish her business. Part A, she decides to rank each location according to certain criteria, such as price of the store and parking facilities. How many different ways can she rank the 5 locations? Well, I have 5 locations, and I'm trying to put them in a certain order. So I have 5 factorial. 5. The other way you can think about it is there are 5 choices for the top ranking restaurant or store, location. That means there are 4 choices left to rank second. There are 3 choices left to rank third, 2 choices to rank fourth, and there's 1 left over for last place. If I multiply these together, I get 120. So if I'm trying to arrange 5 things in a certain order, I do 5 factorial. If you can't remember that, then I'm doing 5 choices for the first, 4 for the second, 3, 2, 1. Kids, that's the definition of a factorial right there. All right, part B, the business owner now wishes to rank only the top 3 of the 5 locations. How many different ways can she rank them? Well, in this situation, we're not arranging all 5. So let's arrange the top 3. Here's the spots for the top 3. Well, there are 5 locations to choose from as the top 1. There are 4 locations left to choose from for top 2. And then there are 3 locations left to choose from for third place. Multiply these together and I get 60 ways I can rank 1, 2, and 3. Awesome. Okay. So this leads us to our first permutation rule. Permutation rule number 1. The arrangement of n objects in a specific order using r objects at a time is called a permutation of n objects taking r objects at a time. It is written by NPR, so it's a little n, a regular p, and a little r. NPR. And we're going to use this formula right here. NPR equals n factorial over n minus r factorial. Don't worry, you don't have to memorize it. Go with it for a moment. So here's our first example. A radio talk show host can select 3 of 6 special guests for her program. The order of appearance of the guests is important. How many different ways can this be done? Okay, so I have n equals 6 guests. That's my total amount that I'm choosing from. My R is how many I am choosing. So I've got my R and I've got my N. So that means that I'm doing 6P3. From a group of 6, I am choosing 3. And those 3 I am choosing are going to be put in a certain order. That's what makes it a permutation, kids. Specific order. I'm taking the 3 special guests and I'm putting them in a specific order. Another thing is that the first number is always going to be bigger than the second number. Always. Now, according to the definition, it's n factorial, which is 6, over n minus r factorial, or 6 minus 3 factorial. So that means on top you have 6 factorial. On the bottom you have 3 factorial. Now you cannot divide those and get 3, or you can't divide them and get 2. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. So look at that. I can cross off the 3s, I can cross off the 2s, I can cross off the 1s. And I'm left with 6 times 5 times 4, which is 120. Well, guess what, kids? I could have also said, hey, I got 3 slots on my program. There are 6 people I can choose for the first spot, and there are 5 people I can choose for the second, and there are 4 people I can choose for the third. Multiply those together. Guess what you get? 120. So there's lots of different ways you can do this, but each time you get 120. Guess what? This number is on your calculator too. You ready to see it? Grab your calculator. So if I go to math again and I go to probability again, look at that NPR number 2. Now you got to type the N number first, and then the P and then the R. Some of the newer calculators, you can go right to it, but this one's a little bit older. So I have to type 6 and then go to math, prob, and I'm picking number 2 for the P, and then I'm going to type in 3, and then I'm going to hit enter. Look at the magic, kids, 120. Awesome. Okay, let's do the next one. A school musical director can select 2 musical plays to present next year. One will be presented in the fall and one will be presented in the spring. If she has 9 to pick from, how many different possibilities are there? Well, I can think of these 9 that I'm picking from, and I'm picking 2. Those 9 plays that I'm picking have to be in a certain order. One is going to go in the fall and one is going to go in the spring. So since the order is important, I can use this permutation rule. And I can say 9P2. From 9 plays, I am picking 2 and I'm putting them in a particular order. So I can go to my calculator and I can do 9P2. 9P2 and hit enter, and I get 72 different ways. Now, another way to think about this is I'm going to put on 2 plays next year. I have 9 plays to choose from for the fall, and I have 8 choose from in the spring. Multiply them together, you get 72 again. So either way you think about it, you get the same answer. All right, now what if order doesn't matter? We now have something called a combination. So the difference between a permutation and a combination is that in a combination, the order or arrangement of the objects is not important. So remember, in contrast, order is important in a permutation. So a combination without regard to order is called a combination. So here at the bottom is your formula. Little n, big C, little r. Again, the n is always going to be the bigger number. So here's what I mean about order. In permutations, whatever event A was and whatever event B was, that was different than doing B first and A second. But in combinations, event A and then event B is the same as doing event B and event A. It doesn't matter what order the objects are in. And so the most important thing you need to pay attention to in these problems is whether order is important or not. Notice the formula for NCR has all those factorials in it, but it's got a new factorial in the bottom. There's a second one in the bottom. But kids, guess what? There's a NCR button right on your calculator underneath the NPR button. So you get to use the calculator again. So let's take a look and see how we do these. So how many combinations of 4 objects are there taken 2 at a time? So that means I have 4 things and I'm trying to take 2 at a time. So these 2 and these 2, or I can do these 2 and these 2. And the order does not matter because I'm just grabbing 2 objects. So that's a combination problem. Your N is 4 and your R is 2. So you have 4C2. So by definition, that's 4 factorial over 2 factorial, 4 minus 2 factorial. Well, on top, that's 4 times 3 times 2 times 1. On the bottom, that's 2 times 1 times, well, 2, another 2 factorial, 2 times 1. Well, guess what? These guys go away. These guys go away. And I get 12 over 2, which equals 6. Okay, so that's what the formula. If I just straight use my calculator and do 4C2, well, I get, let's see, I need to put the number in first. So 4 math prob 3 2. Oh, look at that. You get 6. So either way, you're going to get the same answer. There's not really a way to do this by drawing all those little underlined lines. So you kind of have to use the formula. All right, let's do another. An advertising executive must select 3 different photographs for an advertising flyer. If she has 10 different photographs that can be used, how many ways can she select 3 of them? Okay, so we have 10 that we're getting the photographs from, and we're trying to grab 3 of them. Now, those 3 photographs that I'm grabbing are not going in any specific order in the ad or in the flyer. I'm just going to put the 3 in somewhere. Now, if I was putting those 3 ads into a flyer in a particular order, then I would be using a permutation. But since my 3 ads are just, or my 3 photographs are going just into the flyer, not worried about the order, that makes it a combination. So I have 10C3. And if I do 10C3 on my calculator, sounds like C3PO. If I do 10C3, I get that there are 120 different ways. That answer keeps coming up a lot. So 120 different ways that she can select 3 of them. Again, no particular order. Because look what happens if I want to put those same ones in order, kids. So watch if I do 10 and then I do P. 3. Oh, 10 P 3. Now I have way more possibilities, 720. So kids, notice that. 10C3 is 120. 10P3 is 720. So when I have to put them in a certain order, it makes way more possibilities. All right, last one. In a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. How many different possibilities are there? Okay, well, you have men and women. Well, those are independent events. They're not going to influence each other. So if I find the number of ways that I can choose the women and then find the number of ways that I can choose the man, then I can multiply them together and I'll find the total number of possibilities. So let's do the women first. So I have 7 women and I am taking 3 of them. That sounded bad, but go with it. Okay, so that's 7C3. Now, if I was picking them to be in specific positions, like president, vice president, treasurer, then that would be a permutation problem. But because I'm just asking them to join my committee, that's a combination problem. Okay, and then for the men, I have 5C2. So if I do this on my calculator, 7C3 is 35, and 5C2 is 10. So that gives me 300 and different possibilities of forming my committee. All right, kids, last slide. Last slide is a summary of the different rules. So we have 4 rules: fundamental counting rule, permutation rule number 1. We didn't talk a ton about permutation rule number 2. It just assumes that you have duplicates of things. And so notice at the bottom of the fraction adds factorials for each thing that is being repeated. And then finally, the combination rule. All right, kids, let me know if you have any questions. And as always, keep calm and keep trucking.